In this video, I will show you how to build your own custom keyboard. I recommend you watching the whole video before you start on your own. Have fun watching. This process takes 6 steps. Step 1. Decide what you want. At first, you should decide what format you want your future keyboard to be. The standard you have for sure in front of you right now is the row staggered keyboard, where each row is slightly offset to the side. But there are more ergonomical styles. For example, ortholinear, split and column staggered. In my case, I'm building a split keyboard with staggered and tilted columns. Step 2. The equipment. Now that you've decided on what exactly you want, you need some equipment for the build. I will just show you what's needed for this specific keyboard. If you want to build a different one, adapt it to your needs. So what you definitely need is 2 microcontroller. I'm using 2 RP2040s, 60 switches, 2 rotary encoders, 60 keycaps that fit the design, 62 diodes, 1 for each switch and encoder, 2 TRRS and headphone jacks, a TRRS cable, some kind of cables for wiring, screws and counter nuts, foam for gasket mounting, soldering iron and solder, some tools, a computer and a 3D editing software. On top, I recommend you to have a 3D printer and a GitHub account. Step 3. Model your keyboard. Go to the website keyboardlayouteditor.com to design your layout in an easy way. On the start page, there's an example of a numpad. Mark everything and delete it. Add some keys by pressing Add key or use the keyboard shortcuts. You can change width, height and rotation of the keys. So now start and design the keyboard exactly like you want. To help with the key position, you can also type in the legends of the keys. So here's my version of the keyboard's left side, except of the thumb keys. I have to move these later in the editing software. The right side will look the same but mirrored. Now switch to the raw data tab, copy that all and switch to the website builder.skillkb.com. Paste the layout here, select the switch type MX style and press Draw My CAD. It creates a keyplate model based on your data. Download this DXF file. The next steps are done in a 3D editing software. Mine here is Fusion 360. Create a new project and import the DFX file. Delete the outlines and move the low squares to the intended spot and fix them all with the lock symbol. Add a matching border around these. I will do it in 3mm distance. I also measured my encoder and added a frame, a secure hole and feet for it. Create areas for the gasket mount on the sides. Then we have to offset the north and south side of the holes by around about 1mm for the switches security pins. Extrude the plate in 2 to 3mm. The surfaces around the holes just in 1.4mm. I also added some cable guides where I considered them as useful. After the key plate's finished, I recommend you 3D printing and testing it before you continue. Now start to design the case around it. Be creative. Check tolerances for printing, especially for the cutouts of controller, USB port, TRS connector and the screws. This here is my version of it. I also added a support for the controller. While designing it, I test printed a few versions of the connector holes. The last step is to add a construction level next to the model and mirror everything. When you're finished, export every part of the model as 3MF or STL files. Step 4. Printing. Import your files one by one in a slicer, for example Cura. For some parts you may need supports. Hit print and wait. Here we are. The print is finished and cleaned. Step 5. Building. Put all switches in the plate, then put all keycaps on and turn it around. Now you have to wire the switches in a matrix. I will begin with the rows. Here I will put the diodes in. I advise you to coil these up before using. This makes soldering them on much easier. The installation direction is not crucial, but it is important to mount them all in the same direction. After that we have to wire the columns. Now that the matrix is complete, you need to solder all connections. Then connect every row and column one by one to the microcontroller. Leave some space in the cable so that you can still move the controller. Look at the manual which pin can be used and which not. Also solder the TRS port to the microcontroller using 5V ground and 2 UART pins. Take your piece of foam, cut it in pieces and glue them on the outstanding surfaces of the plate. Take the case's top side and press the counter nuts with heat in the intended holes. The last step of the building process is to put everything in the case and screw it together. Repeat the same for the left side. Step 6. The firmware. For easy coding, I'm using a firmware tool called QMK. For that you need QMK MSys2 and the QMK firmware repository on your computer. There's enough documentation on how to set up the QMK build environment, so I'm not gonna show you here. Start QMK MSys and type in new keyboard and press enter. It's gonna ask you for the keyboard's name. The convention here is that it will get in the handwired folder. So type in handwired / your GitHub username to create a folder / the keyboard's name and press enter. Then it will ask you for your GitHub account. Mine's pre-selected here, so press enter again and then it asks for the real name. Just type that in, press enter. A list of default layouts appears. This keyboard is not a usual layout, so we'll select none of the above. Number 62, that's pre-selected, so just press enter. Then a list of available microcontrollers appears. We are using the RP2040, so type in 37 and press enter again. A folder with the keyboard's name is created. Just mark that and cd into it and open it in Visual Studio Code. Inside of VS Code we're beginning with the info.json, where we have to change quite a lot. On top we're gonna change the keyboard's name to what it actually is, Nico Split. That's what your computer sees the keyboard as. Behind the point diode directions we can now indicate in which direction we connected the diodes. In my case it's rows to columns. After that we look at the matrix pins. Just specify the pins for the rows and columns on the left side here. The pins for the right side are expected to be the same. We are also changing the vendor ID. Here I'll take the hex version of my initials. NK is related to 4E, 4B. The vendor and product IDs are how your computer identifies this keyboard. You can't use two keyboards with the same IDs at the same time. I'm also adding boot magic so I can easily reflash the keyboard's firmware and the dynamic key map layer count, because I'll work with multiple layers as shown later. Next step is to define the matrix of the keyboard. A layout author 4x4 is predefined, but we have to get there our own layout. Within the syntax we'll now type in all key positions as arranged in the editor before. The first number is the row and the second is the column. I will not create it with the tilde keys. You can stay in a much easier matrix unless you plan on using RGB in the future, so in my case it looks like this. Note here that the split definition doubles the rows, not the columns, so on the left side we have rows 0 to 4, on the right side 5 to 9. Switch to the config.h file. Here will be defined the pins for the rotary encoder. Because I will use two encoders in a split layout, I'm just gonna add the pins for the left side, same as with the matrix pins. In addition, I'll add the encoder's default resolution. For the communication between the two sides, we'll add the instruction to use full duplex and specify the pins for it. I decided to use GP0 and GP1. To identify which controller is which half, I will add a definition so that this is set by the flashing option saved in the EEPROM. To help the sides negotiate who's master and who's slave, we added a program, the watchdog. I'm also adding boot magic for the right side to the upper right button. Switch to the rules.mk file. We have to define that we'll use a split layout and the MCU's own driver for serial communication between the halves. We are also adding encoder support and the encoder map. Switch to the keymap.c file. Here we'll adapt the given keymap. This should match the info.json's layout. Type in the keycodes you want in rows separated by commas. Check the available keycodes on QMK's website. You don't have to format it like your layout, but it'll be easier for you. So this is my keymap. I will use it with the standard QWERTY layout for the alpha keys. As you see, I added 3 more layers and layer shift keys. Because of the encoder, we have to add a few lines for the encoder map, also with 4 layers. Last step is to separately flash the microcontrollers using the correct side's bootloader, left for the left side, right for the right side. After that, connect the 2 sides via the TRS cable and connect one side to the computer. Now you know how to build a keyboard. If you have questions or thoughts you want to share, leave a comment below. Thanks for watching.